This lesson is on solving logarithmic equations. Often the answer may or may not be irrational. You might need a calculator, may not need a calculator. But we're going to follow these steps. That if we have multiple logarithms, we're going to condense them into one logarithm on both sides. If we have one log on one side and one log on the other side, then you can take what's on the insides of each logarithm and make them equal to each other and solve it. Here's a big thing, is that word again, right? Hasn't that shown up too many times? Why could there be extra solutions here, or extraneous? Is because of the domain restriction. You know, you just graphed a logarithm. Didn't you have an asymptote? And the whole picture is to the right, not to the left. And so we need to be aware that what's inside the logarithm cannot be 0, cannot be negative. What's inside the logarithm cannot be 0, cannot be negative. So when you get an answer, you have to check it at the end to make sure it doesn't equal 0 or is a negative number when you evaluate it inside the logarithm. Did you get that? So it can only be positive numbers inside the logarithm. All right, so let's start. So first thing I look at, is there more than one logarithm on the left or right? No. Next thing I look at, are the logarithms have the same base? If they didn't have the same base, then you couldn't do the next step. And the next step is, okay, we got one logarithm equaling another logarithm. The bases are the same. Then you take what's inside equal to the other side of what's inside. What type of equation is this now? It's no longer a logarithm, but it's now linear. How do I solve a linear? Combine like terms. So a good step would be subtract 5. And another good step would be to add 1. And then divide. So we get the answer x equals 9. Now what x is could be positive or could be negative. That doesn't matter. What matters is if I take that answer and go back inside the logarithm, will it give me a positive answer? So if I go back 7 times 9, take away 1. Positive answer? 5 times 9 plus 17. I don't even write. It's a positive answer, so it's a good solution. If I go back and realize it gives me the answer 0, or it gives me a negative answer inside the logarithm, then it is extra and you cross it out. Number 2. Do we have one logarithm equaling another one? Are the bases the same? Yes, e. So then take what's inside and make them equal to each other. What type of equation is this? This is no longer a log, it's now a quadratic. How do I solve a quadratic? Is I make it equal to 0, factor, I hope, and solve. Yes? So how do I make it equal to 0? Well, I'm going to combine like terms. So I'm going to subtract k. So if I subtract k, how many k's are there on the left side? And then I'm also going to subtract what number? 14. What two numbers multiply to 14? And they subtract, right? I heard it, negative 7 and 2. Each factor has a solution. So what's the 0 for the first factor? And for the second one? Now what do I have to do? Is if I take the answer and you put it in, 7 squared is 49. 4 times 7 is 28. When you subtract, it will be a positive answer. And then 7 plus 14, positive answer. Negative 2 squared, and a negative times a negative, that actually is positive. And negative 2 plus 14 is still positive. Both answers are good. But I have to check to make sure that it doesn't have a negative or a 0 inside the logarithm. Number 3, what do you notice here? We have two logarithms. What property can I use to write that as one logarithm? If you're adding and the bases are the same, to write them as one logarithm, you multiply. Now, do I have one logarithm on the left and one logarithm on the right? The bases are the same. So what will I make equal to each other? What's on the inside? And then solve it. what type of equation is this? Is it linear or quadratic? It's linear because the degree is 1. So that means I just have to distribute, combine like terms, get c by itself, and we're good. So 4c plus 12 equals 8. Subtract 12, and then divide. And then what do I have to check at the end? There's only one logarithm with a variable. So if I plug -1 in, is that a positive answer inside the logarithm? Number 4. Step number 1. I need to write it as one logarithm. What property am I going to use to write it as one logarithm? So I'm going to divide what's in the numerator and then what's in the denominator. All right, on the right side, what property am I going to use for the 1/3? Where does it belong? As an exponent. Now do I have one log equaling another log? Now are the bases the same, right? So what's on the inside you make equal to each other. Do you remember what 8 to the 1/3, what that means? The cube root of 8. Is that our number? 3 times itself equals 8?
Yes.
What number is that? Just 2, right? So next, I'm going to multiply both sides by 5w, take away 3. And then I combine like terms and solve it. So I'm going to add 6, I'm going to take away 1, and then divide. If I put 12 over 9 inside the logarithms, it would give you a positive answer. Number 5. Yes? Could you write that in a simplified way?
Yeah.
Yes, you could. But you don't have to. So if you wanted to write that and divide top and bottom by 3 and write down 4/3, you can. Number 5. Step number 1. I have a logarithm on the left. One thing I have to do you see the number in front of the logarithm? That is going to be the exponent inside. Once everything is inside one logarithm, then I can make inside equal to inside. So on the left side I have 4p plus 3. And on the right side, do you remember what the exponent 1/2 means? It means square root, doesn't it? Does that simplify? What's the square root of 16? And square root of 4? P to the 4. Divide by 2, right? What type of equation is this now? So for a quadratic, it needs to be equal to 0. So I'm going to subtract 4p and subtract 3. This is not a simple quadratic. So in order to do it, what do I need to do to factor it? 4 times -3 is -12. -4 underneath. And then what two numbers fit? They multiply to -12 and add to -4. So then I go back into the equation and I take out the -4 and put in -6 plus 2, and I still have a subtract 3. Then we're going to factor by grouping. So if you take the first two and group them, what do they have in common? 2 and p, and what's left over after you factor them out? And the second two, they have nothing in common, only a 1. So one factor is 2p subtract 3, and the other factor is 2p plus 1. Each factor has a 0. What is the 0 from the first factor? Positive 3 over 2. How about the second one? Negative 1 over 2. Check out, make sure. A positive number would be positive. A negative number, well, for the second one, the even exponent makes it positive. And then 4 times negative a half is negative 2 plus 3. So both answers give me a positive number inside the logarithm. Number 6. The number in front is the exponent. Here, what can I do with these two numbers is I can divide them. Do you know that 80 divided by 5? Do you know what that answer is? 16, and then that's to what exponent because of the 3 over 2, right? So I divide, and then the number in front is the exponent. Now we have a plus 1 squared is equal to do you know how to do this? What's the square root of 16? 4. And what's 4 cubed? This is a quadratic, but the good news is this is like completing the square. It's already completed, right? I don't need to expand it. It's ready to go. So what can I do to both sides to undo it? And then the answer is positive or negative what? 8. And then what's the last step? Is to subtract 1. So what's 8 subtract 1? What's negative 8 subtract 1? Now, what do I have to be careful about? What happens when I put negative 9 into the logarithm? Negative 9 plus 1. That's an extra, isn't it? Positive 7 works. So the only solution is positive 7. Why did I cross out negative 9? When you plug it back inside the logarithm, negative 9 plus 1 is a negative answer. That's our domain restriction. It can't be negative. Turn the page. Here's a second type of logarithm equation when you have a logarithm on one side and a number on the other side. So if we have more than one logarithm, we're going to condense it into one logarithm. But at this step, we're actually going to write it in exponential form to solve it. So when you have a logarithm equaling a number, you have to write it as an exponential. I know, it's getting red, isn't it? Oh, it listened to me. Now it's yellow. 7. Hey, do you know how to write this as an exponential? Yes, you do. Hey, what's inside the logarithm? 3x minus 4. What's the base? 2. And what's the exponent? So I'm going to write down what's inside the logarithm, and then the base and the exponent. 2 to the 7. You know what that is? I think it's 128. And now it's just a linear. Add 4 and divide. And it goes in evenly 44 times. Again, what do I have to check? If I put in 44, it's a positive answer inside the logarithm. Again, ln 2a equals 9. In order to solve this, I need to write it exponentially. Are you with me, Amelia? So what's inside the logarithm? 2a. What's the base that you don't see? To what exponent? And then to get a by itself, what would you do? Divide. Here's an example you need your calculator. The exact answer is e to the 9 divided by 2. what would the answer be if you approximated it? Do you know how to use your calculator? So, do you remember where E is on your calculator? It's in yellow. So diamond X, there's E to the 9, and then divide it by 2. So can you show yourself that you're able to type that into the calculator and get that answer? Now's a good time to talk to me if you don't know where E is on your calculator, if you can't type it in. Are we okay? Those that have the N spires, it's really obvious, right, where the E is to type it in. Wait, number 9. Step 1 in number 9 is I want to isolate the logarithm. So in this example, I need to add 2. I need the logarithm completely by itself. If there's anything in front or behind it, I need to undo that first, make sure it's all by itself. At this step, we have to write it as an exponential. So I'm going to remind you again, how do I write that as an exponential? Do you see what's inside the logarithm? Write it down. What's the base? And then what's the exponent? Now this one's simple. 6 squared is 36. When you subtract 7, you get 29. Check. Yep. It gives you a positive answer inside the logarithm. All right, number 10. Do you see something in front or behind it? I need to undo that first. And I need to get the logarithm by itself. So 5 take away 4 is 1. I could write it as an exponent, but I don't really want to because it makes it more work. I'd rather just divide by 2, though you'd get the same answer both ways. But I think that would be a little bit easier. And of course the base is 9. At this step, once you have the logarithm isolated, you write it as an exponential. So how do I write this as an exponential? What's inside the logarithm? What's the base? And what's the exponent? Remember, the exponent 1/2 means square root. So what is the square root of 9? So it's a quadratic. So I'm going to subtract 3 to make it equal to 0. Can you factor this? What two numbers multiply to -3 and add to 2? That would be k plus 3 and k minus. So one answer would be -3 and the other answer would be +1. Check. +1 is obvious. It works. -3, well, that becomes +9 take away 6. So both give you a positive number inside the logarithm. Number 11. Do you see in number 11 you have 2 logarithms? So step 1 is to combine them together. So when you're adding, how do you combine them together? Is by multiplying. Now that you have one logarithm, how do I write it as an exponential? What's inside the logarithm? Do you notice a structure to what's inside the logarithm? It's 2v plus 3, 2v subtract 3. That's called the difference of squares. So all I have to do is first times first and last times last, and that's what's inside the logarithm. What's the base? 4, and what's the exponent? 2. What is 4 squared? Add 9. And then the last step is 2. Or the next step is to divide. Now, this is still a square. What do I have to still do at this point? When you solve a quadratic, the answer could be positive or negative. What is the square root of 25 and the square root of 4? What should I write down? And the other one would be... Now, can you check? The positive answer gives me a positive number underneath. But what happens to the negative one, especially on the second one? If you plug a negative number in, you have a negative number, subtract 3. This one is extra. Because if I plug that one into the logarithm, it gives you a negative number inside the logarithm. So you have to check to make sure it gives you a positive answer. Negative 5 over 2 gives you a negative answer. So what's the only solution? 5 over 2. Number 12. To combine these together, I'm going to use some properties. So do you see the 1/3? Where does it belong? As an exponent. What does 27 to the 1/3? What does that mean? The cube root. What is the cube root of 27? Next, I need to write this as one logarithm. Then I can write it as an exponential. One logarithm. So do you see the adding? To write it as one logarithm, what would you do? Multiply them. We're now ready to write it as an exponential. So what's inside the logarithm? Write it down. What's the base that you don't see? E. And then what's the exponent on E? 4. So we're going to have to use your calculator. Not yet, though. The next step is to add 15. And then what would the last step be? Divide by 3. So let's use your calculator right now. So we're going to go E to the 4. Make sure you close the parentheses. And then plus 15. Get an answer. And then what that answer is, you divide that answer by 3. And you get 23.199. Are you able to use your calculator to get that answer? These next days going forward, we need to be comfortable with our calculator to know where E is, ln is, to do a logarithm. Number 13. Step number 1. Can you write that as one logarithm? So when I see adding, how do you write it as one logarithm? Is by multiplying. Next, now that I have one logarithm on the left, how do I write that as an exponential? So what's inside the logarithm? And if I multiplied it out, I'd have n squared. Negative 3 plus 1 is negative 2n. And negative 3 times 1 is negative 3. So I FOILed easily as I'm doing it. So what's inside, I write down. What's the base? And what's the exponent? Two to the exponent 5 equals 32. To solve this, I need to make it equal to 0. So I'm going to subtract 32. Now I have negative 35 when I subtract. What two numbers multiply to negative 35? And negative 2. So negative 7 and... So what's the 0 from the first factor and from the second factor? What must I do at this point? So if I plug in positive 7, does it give me a positive answer? What happens to negative 5 when I plug it in? So what's the only solution there? The only solution is 7. All right, one more for logarithms. Then we're going to solve exponentials with our calculator. So, 14, step number 1. Can you write that as one logarithm? You try. Can you write it as one logarithm? And then you're going to write it as an exponential. Do you see that subtract sign? That means what are you going to do to write them together? Subtracting leads us to dividing. Adding leads us to multiplying. So we're dividing. Next, can you write that without a logarithm? Can you write that as an exponential? How do you do it? So what's inside the logarithm? What's the base and what's the exponent? Two squared is 4. Next, I'm going to multiply both sides by 3c subtract 5. So I have c squared is equal to 12c minus 20. What type of equation is this? A quadratic. How do I solve a quadratic? Make it equal to 0. So I'm going to subtract 12c. I'm going to add 20. Can you factor it? Two numbers that multiply to 20 and add to negative 12. So it's negative 10 and negative 2. What's the 0 from the first factor? And then from the second one? So when I plug them in, will it give me a positive answer? 10, yes. 2, will it give me a positive answer? Well, 3 times 2 is 6. And 6 take away 5 is a positive answer. So both are good solutions. 10 and 2. All right, there's your lesson on solving logarithmic equations.